All right, this is what we'll be doing today in class on the 12th of November, which is Thursday. We're going to review the fact that when I have a projectile, what is a projectile? Projectile is an object that's flying in air in two dimensions. So for example, if I threw a football, I'm flying in both the y direction and the x direction. I'm still in free fall. And free fall by definition is an object that's in flying through air and is not in any contact with any other objects. So in free fall, what we learned when we were in one dimension is that the acceleration in the y direction at all times, even if I'm going up or traveling down, is negative 9.8 meters per second squared. We now know that the acceleration in the x direction at all times is 0. We also know that x and y motion is independent of one another. Let's see if we can talk and spell at the same time. That's very difficult. Is independent. Okay. There is nothing that happens in the y that affects what happens in the x. All of the equations that we have learned in the y direction still apply. Our 5, 4, 3, 2, 1. We have 5 variables, 4 equations. If I know 3 of them, I can find the other 2. However, in the x direction, because acceleration is equal to 0, everything collapses down to one useful equation. Delta x equals vx times time. Because vx initial equals vx final, because of the fact that acceleration is equal to 0. So everything completely goes away. The only variable that can cross the boundaries of x and y dimension is time, because it is a scalar. It has no dimension. Okay, so it doesn't make sense to say 10 seconds north, 10 seconds to the east. Okay, so we can, once we know time and y, we know the time in x. So let's use that knowledge. I'm going to work 2 problems. One is a little bit more, what I'll say, conventional. So I have a house. I throw a baseball from the roof of a house to a friend on the ground. So here's my friend on the ground. Okay, I throw this baseball at an initial velocity of 12 meters per second in the horizontal direction. This is the most important phrase right there. So what does that look like? So it looks like this. I am on the house. I throw it at a horizontal velocity of 12 meters per second. So what is that velocity? That is my initial velocity in the x direction. It is horizontal. What does that imply about my initial velocity in the y direction? That means it's 0. In the horizontal direction. Hold on 1 second. We have an issue. Okay, not sure what just happened, but we're continuing on. All right, so we have the ball traveling initially at 12 meters per second horizontally. That means its initial velocity in the x direction is 12 meters per second. Its initial velocity in the y direction is 0. Well, what have they asked? After 1 second, how fast is the ball moving in the x direction and in the y direction? So what does that look like? Okay, so here we go. It's coming to my friend, and I don't know where it is, but we'll say that's approximately there, 1 second. What do I want to know? I want to know the velocity in the x direction at that time, and I want to know the velocity in the y direction at that time. So let's construct our table. What do we know? We know the initial velocity in the x direction is 12 meters per second. We know the initial velocity in the y direction is 0. We know the acceleration in the y direction is negative 9.8 meters per second squared. We know the acceleration in the x direction, 0. It is all the time, forever and ever. All right, we know the time that we're going to use is 1 second. That will be in both the x and the y directions. And we also have been asked, what is the final velocity at that time? What is that? So I have 3 things in the y direction, do I not? I have initial, I have acceleration, and I know time. So I can find the final velocity in the y direction. I've got to figure out which equation. I have an initial I'm looking for final velocity, so I've got to find an equation up here that applies. And typically we should have an equation sheet on in our hand. So that's going to be my favorite equation because it's my easiest equation, and that is V final equals V initial plus A times T. And so V final is equal to 0 plus negative 9.8 meters per second squared times 1 second. V final equals negative 9.8 meters per second. Now, does that make sense? Does it make sense that, let's say right about there, it has a negative velocity in the y direction? Sure it does, coming downward, okay? What is its velocity in the x direction? So that's part of the answer. That's actually answered to B. Well, what do we know? If the acceleration in the x direction is 0, acceleration, definition of acceleration, change in velocity over change in time equals 0. Well, time's not 0, and we can't divide by a 0 anyway, so we know that velocity change has to be 0. We know that the velocity in the x direction at all times is equal to what it started at. It will not change because of the fact that acceleration in the x direction is 0. So we're going to be exactly at 12 meters per second in the x direction at all times. This is negative 9.8 meters per second, okay? So x velocity final in the x direction is 12 meters per second. Once again, except velocity in the x direction will not change. I have a question for you that is not what they asked. If I'm traveling with a velocity vector in the x direction at 12 meters per second, a velocity vector at negative 9.8 meters per second, which is why it's pointing downward, what is its final velocity? What do they mean by that? Well, they want to know what that question is what is this vector? Well, how would I find it? Final velocity is Pythagorean theorem, right? 12 squared plus 9.8 squared. Let's see if I can. So the final velocity vector, the resultant vector, is 9.8 squared plus 12 squared. Enter. Second function, square root of that. The final velocity is 15, we'll say 0.5 meters per second. And let's say we'll find this angle right there. And tangent of that angle is the opposite side, which is 12, over the adjacent side, which is 9.8. So theta, I'll take the inverse tangent of both sides. And that'll give me 50 degrees. Now that means this angle is 50 degrees, okay? So it's probably easier to describe if you use this angle, which is 40 degrees. So it is at 40 degrees below the, I would say, horizon or positive x-axis, okay? So that is its magnitude. This is its direction, okay? All right, the other thing we might do is this problem right here. I have a person that's skateboarding with a constant speed of 1.3 meters per second. I am at an initial height of 1.25 meters. I want to know, question mark, let's see, I want to know where is the ball after, we'll just do A, which is 0.25 seconds. So we have to construct our XY table. The velocity initial in the y direction is 0 because it was released at a horizontal. Can you see the picture right here? And the velocity in the x direction initial was 1.2, I'm sorry, 1.3. Velocity in the x direction initial is 1.3 meters per second. I know that the time is going to be 0.25 seconds. We also know the acceleration in the y direction is negative 9.8 meters per second squared. I have three things in the y direction, so I can solve. And the only equation that works in the x direction is delta x equals vx times t. Vx is never changing, so it doesn't matter if it's initial or final, it will always be the same. So I can tell you where the ball is easily in the x direction. That's 1.3 meters per second times 0.25 seconds, and that will be equal to 0.325 meters. So it has traveled, if this is x equals 0, by the time it reaches, let's say, t equals 0.25 seconds, the x value will 0.325 meters. Well, where will it be? What's delta y? Well, the equation that you can use, that's a plus 1/2 at squared. The initial velocity in the y direction is 0. All I have is 1/2 negative 9.8 meters per second squared times the time that they gave us. And if I plug that into my calculator, 9.8 times 0.25 squared equals, I will have dropped 0.306 meters. Okay, that tells you how much it changed, how much it fell. Well, where did it start at? It started at 1.25 meters. So I've got to subtract how far it dropped, and that will give me, it will be located at 0.94, I'll call it 4 meters off the ground. So y equals 0.94 meters. Okay. All right. That's what we're going to be doing in class. And then we have a little assignment that is a problem where you have to apply this. That's what I got. Reach out to me if you have any questions.